This is the EdExcel GCSE 9-1 Maths Higher Paper 2 from the November 2022 series, and this paper is a calculator paper. Question number 1. The scatter graph shows information about the amount of rainfall in millimetres and the number of hours of sunshine for each of 10 English towns on the same day. So we have the amount of rainfall in millimetres and the number of hours of sunshine. One of the points is an outlier, and for part A we have to write down the coordinates of this point. Well, to find out which point is an outlier, we need to go to our scatter diagram and look for a point which does not follow the general trend of the other points. And you can see that will be this point here. It has coordinates 2 across and 1 up. So we've got 2, 1. As the amount of rainfall decreases, the number of hours of sunshine increases. And you can see that here. The more hours of sunshine we have, the lower the amount of rainfall. On the same day, in another English town, there were 7 hours of sunshine. Using the scatter graph, we have to estimate the amount of rainfall in this town on this day. Our first step is to create a line of best fit. We want roughly the same amount of points above the line as we have below the line. So something like this would satisfy our line of best fit. Now for 7 hours of sunshine, we read across, then we read down, and what you can see then is there is 3.4 millimeters of rain. So we have 3.4 millimeters of rain. For question 2, the front elevation and the plan of a solid are shown on the grid. On the grid, we have to draw the side elevation of the solid from the direction of the arrow. So, this bit of the plan would correspond with this bit of the front elevation. This bit of the front elevation would correspond with this bit of the plan. Now, when we look at the shape from this view, the total height will be 5. So that would correspond to this bit here. And the width will be 3, which means we have a width of 3 as we see here. And if we complete our rectangle, we've got this shown here. We then have this bit over here going up from the bottom. So we have 1 going up like this, and then we can draw a horizontal line. We then have this height shown here. So that would correspond to this bit here. And then we've got a horizontal line going across. and then the rest of the height will be shown here. And that corresponds with this section here. And so therefore, what you can see is our side elevation shown here. Question number 3. Here are the first 5 terms of an arithmetic sequence, 7, 13, 19, 25 and 31. For part A, we have to find an expression in terms of n for the nth term of this sequence. The first thing we can do is find the difference between each term. You can see the difference between each term is plus 6, and therefore we would have a 6n, and to find the 0th term we have to do the inverse of plus 6, which is subtract 6, and if I do 7 subtract 6 we get 1, so we have 6n plus 1. The nth term of a different sequence is 8 subtract 6n. Is negative 58 a term of this sequence? You must show how you get your answer. Well, what we can do is set this sequence 8 subtract 6n equal to negative 58. So now if we attempt to solve for n, we have negative 6n equals negative 66, which means n is equal to 11. Because we have a whole number for n, we can conclude that negative 58 is the 11th term. Question number 4. The diagram shows a plan of Jason's garden. A, B, C, O and D, E, F, O are rectangles. CDO is a right-angled triangle. AFO is a sector of a circle with centre O, and angle AOF is equal to 90 degrees. Jason is going to cover his garden with grass seed. Each bag of grass seed covers 14 meters squared of garden. Each bag of grass seed costs £10.95. We have to work out how much it will cost Jason to buy all the bags of grass seed he needs. The first thing we can do is find out the areas of the different sections. For the rectangle here, 11 times by 7 is 77. So this area is 77 meters squared. For this rectangle, we've got 9 times by 7. That is 63. So this rectangle has an area of 63 meters squared. For the triangle here, we've got 9 times by 11 times by a half, which is 49.5 meters squared. And for the 1/4 of a circle, well, we've got 1/4 times by pi times by the radius squared. Now the radius here is 7, so we have 7 squared. It turns out we get 49 over 4 pi. So we have 49 pi over 4 meters squared. So now what we can do is find out the total area. So for the total area, we've got 77 plus 63 plus 49.5 plus 49 pi over 4. So if I add these together, it turns out the total area is equal to 227.98 etc. meters squared. So now what we can do is find out how many bags we need. So for the total number of bags, we would have the area of 227.98 etc. divided by 14 because each bag of grass seed covers 14 meters squared. So if I divide this value by 14, it turns out the total number of bags we need is 16.28, etc. So in other words, we need 17 bags. Now we know that each bag costs £10.95, so therefore the total cost is equal to 17 multiplied by £10.95, and if I multiply 17 by £10.95, it turns out we get £186.15. Question number 5. We've got this right-angled triangle. We've got a length of 14.5 centimeters, a length of x centimeters, and an angle of 53 degrees. We have to work out the value of x to three significant figures. Well, we've got the hypotenuse and the adjacent, and what connects those is cosine. So we have the cosine of 53 degrees. That will equal the adjacent x divided by the hypotenuse 14.5. We need to find out the value of x. So therefore x is equal to 14.5 times by the cosine of 53 degrees. And if we work out what this is equal to, it turns out we get a value of 8.726, etc. centimeters, which to three significant figures is 8.73. Question number 6. Ella invests £7,000 for 2 years in an account paying compound interest. In the first year, the rate of interest is 3%. In the second year, the rate of interest is 1.5%. We have to work out the value of Ella's investment at the end of 2 years. Well, the amount that she would have that will equal, well, we've got the 7,000. Then in the first year, we've got 1.03. And in the second year, we've got 1.015. So if we work out what this is equal to, we have 7,000 multiplied by 1.03 times by 1.015. It turns out we get 7,318.15. So we have 7,318.15. Question number 7. Here is the graph of y equals x squared subtract 6x plus 4. For part A, we have to write down the y-intercept of the graph of y equals x squared subtract 6x plus 4. Well, to find out what the y-intercept is, that's where the graph crosses the y-axis, and you can see that is at the point 0, 4, so the y-intercept is 4. For part B, we have to write down the coordinates of the turning point of the graph of y equals x squared subtract 6x plus 4. Well, to find out the coordinates of the turning point, going back to our graph, you can see the turning point is here, and the coordinates we've got 3, negative 5. So the coordinates of the turning point, we've got 3 and negative 5. For part C, we have to use the graph to find estimates for the roots of x squared subtract 6x plus 4 equals 0. Well, we can find the roots by looking at where the graph equals 0. And if we go back to our graph, it equals 0 here and here. So we can conclude from that then, we've got values of x being 0.8 and 5.2. Question number 8. Chanda buys a necklace for £120. She sells her necklace for £135. We have to work out her percentage profit. First of all, the profit is equal to 135 subtract 120. So it turns out her profit is equal to £15. The percentage profit then will equal 15 divided by the original amount of 120, and then we multiply this by 100. So we have 15 divided by 120 times by 100. It turns out we get 12.5. So it turns out her percentage profit is 12.5%. Question number 9. Here are the equations of two straight lines. We've got y equals 1/2 x subtract 6. Then we've got 6y equals 3x plus 7. Oscar says that these lines are parallel. Is Oscar correct? You must give a reason for your answer. Well, if we have 6y equals 3x plus 7, then what we can do is rearrange so we have y equals. And we can do that by dividing through by 6. Dividing through by 6, we have y equals 3 over 6 x plus 7 over 6. 3 over 6 we can simplify even further. So we are left with y equals 1/2 x plus 7 over 6. Now what you will find is our gradient here is 1/2. Our gradient here is also 1/2. So what we can say is, because both lines have a gradient of 1/2, the lines are parallel. Question number 10. Alia bought a car. In the first year after she bought the car, its value depreciated at a rate of 23% per annum. In the second year after she bought the car, its value depreciated at a rate of 19% per annum. At the end of the second year, the car was worth £10,914.75. What was the value of the car when Alia bought it? If we let the original value equal x, then we have x multiplied by, well, it depreciated at a rate of 23% in the first year, so we multiply by 0.77. This 0.77 would correspond to the depreciation of 23%. Then we multiply this by, well, if it depreciates at 19% per annum in the second year, we multiplied by 0.81. So this 0.81 would correspond with the statement where it depreciates at a rate of 19% in the second year. And the final value of all this is equal to 10,914.75. So we have x equals, well, we've got 10914.75, and then we divide this by 0.77 times 0.81. So if I work out what this is equal to, we've got 10914.75 divided by 0.77 times 0.81. It turns out we get 17,500. So we have a value of 17,500. Question number 11. In an experiment, 60 students each completed a puzzle. The cumulative frequency graph shows information about the times taken for the 60 students to complete the puzzle, and that's what we see here. For these 60 students, the least time taken was 24 seconds, the greatest time taken was 96 seconds. On the grid below, we have to draw a box plot for the distribution of the times taken by these students. Well, what we know so far is the least time taken is 24 seconds. So we would have to draw a vertical line down at 24, and that would be over here. So this would correspond to the least time. Then we know that the greatest time is 96 seconds. So we draw a vertical line down at 96. 96 is over here. We draw a line down like so. So we have the greatest time. Now if we go to our cumulative frequency graph, what we can do is find the median, the lower quartile and the upper quartile. For the median we would have half of the 60, which is 30, so we draw a line here, and then we draw a line down from here, and what you can see is we have 52. So we draw a line down from 52 like so. For the lower quartile, half of the 30 is 15, so we draw a line across from 15, and then we draw a line going down, so we would have 42. So at 42 we draw a line like so, and then 3/4 of 60, that's 45, so we draw a line across to here, and then draw a line down to a value of 64. So we have 64 here. And if we now join these up, like so, here is our completed box plot. Question number 12. The number of insects in a population at the start of year n is Pn. Then we know that the number of insects in the population at the start of year n plus 1 is Pn plus 1, where Pn plus 1 is equal to k times by Pn. We're given that the value of the constant k is 1.13, and for part A we have to find out how many years it takes for the number of insects in the population to double. You must show how you get your answer. Well, if we know that k is 1.13, we can say then Pn plus 1 is equal to 1.13 times Pn. Now in year 1, in other words when n is 0, P1 that's equal to 1.13 times by P0. Can't do much with that. In year 2, P2 that's equal to 1.13 times by P1, and we already know what P1 is, so we've got 1.13 times by 1.13 P0. In other words, 1.13 squared times P0. In year 3, we've got P3 that will equal 1.13 multiplied by P2. So we've got 1.13 times by 1.13 squared times P0. In other words, we've got 1.13 cubed times P0. Year 4, we've got P4 that's equal to 1.13 times by P3. So we've got 1.13 times by 1.13 cubed times P0. So we've got 1.13 to the 4 times P0. Year 5, we've got P5 that's equal to 1.13 times by P4 times by 1.13 times by 1.13 to the 4 P0. So we've got 1.13 to the 5 P0. And in year 6, P6 that's equal to 1.13 times by P5. So we've got 1.13 times by 1.13 to the 5 P0. So we've got 1.13 to the 6 times P0. Now what we're looking for over here is how many years it will take for the number of insects in the population to double. So what we are looking for is 2 times by P0 essentially. So if I actually work out these values, 1.13 squared, that's equal to 1.2769 P0. And if I work out 1.13 cubed, we've got a value of 1.44, etc. P0. Then where we've got 1.13 to the 4, it turns out here we have 1.63, etc. P0. And then where we've got 1.13 to the 5, we would have 1.84, etc. P0. And where we've got 1.13 to the 6, that leaves us with 2.08, etc. P0. And because this value here is greater than 2, what we can say then is it will take 6 years for the number of insects in the population to double. The value of k actually increases year on year from its value of 1.13 in year 1. How does this affect your answer to part A? Well, we cannot tell because we do not know how much it is increasing by. So we don't know how long it will take, in other words. Question number 13. A and B are points on a centimetre grid. A is the point with coordinates -7, 6. B is the point with coordinates 8, -5. We have to work out the length of AB correct to one decimal place. Well, if I create a right-angled triangle with the points given, we've got A with coordinates -7, 6 and B with coordinates 8, -5. Now, to go from the -7 to the 8, we add 15. And to go from the 6 to the -5, we subtract 11. So, when we come to work out the length AB, which we will call x, we can use Pythagoras. If we use Pythagoras, x squared is equal to 15 squared plus the 11 squared. So if I work out what x squared is, 15 squared plus minus 11 squared, that's 346. So we have 346. And to find out what x is, we square root. So that means the value of x is equal to 18.601, etc. So we have to one decimal place 18.6 centimeters. Question 14. Using algebra, we have to prove that 1.062 recurring can be written as 1 and 14 over 225. So, the way we can go about this is as follows. If we let x equal 1.06222, etc., because we've got one digit repeating itself, we can multiply by 10 to say that 10x equals, well here, if I multiply by 10, I get 10.62222, etc. So now what we can do is subtract these. And if I subtract these, 10x take away x, that's 9x. So we have 9x equals, well here we've got the 10.6 to subtract the 1.06, which is 9.56. So we've got 9.56, and that's because these terms would cancel. So if 9x is equal to 9.56, we can find out what 1x is. So that's equal to 9.56 divided by 9. So that is the same as 956 divided by 900, and 900 goes into 956 one whole time, and what's left over is 56 over 900. And if we work out 56 divided by 900, we get 14 over 225. So we get a value of 1 whole and 14 over 225. And that's exactly what we wanted to show. Question number 15. Liza is studying the population of rabbits in a park. She wants to estimate the number of rabbits in the park. On Monday, she catches a random sample of 20 rabbits in the park, marks each rabbit with a tag and releases them back into the park. On Tuesday, she catches a random sample of 42 rabbits in the park. 12 of the rabbits are marked with a tag. For part A, we have to find an estimate for the number of rabbits in the park. So what's happening over here is we've got a population of rabbits. What she's doing is, from this entire population, on Monday, she grabs a sample of 20. Now, if I say the total population is n, then out of n, she catches 20 of them. Then on Tuesday, she's got a sample of 42 from here. So here is the 42 rabbits. And from these 42 rabbits, 12 of them have a tag. So we've got 12 out of 42 altogether with the tag. And to find out the total number of rabbits, what we can do is assume that the proportion of rabbits with a tag remains the same. So if we begin by letting n equal the total number of rabbits, then we have 20 over n, which is equal to 12 out of 42. So we need to find out what n is. So to find out what n is, that's equal to 20 times by 42 over 12. And if we work this out, we've got 20 times by 42, divide that by 12, we get 70. So we have 70. Albie is studying the population of rabbits in a wood. One day he catches 55 rabbits and finds that 40 of these rabbits are marked with a white tag. Albie estimates that there are 50 rabbits in the wood. We have to explain why Albie's statement cannot be correct. Well, the sample size cannot be greater than the population size. Question number 16. The shaded region shown on the grid is bounded by 4 straight lines. We have to find the 4 inequalities that define the shaded region. Well, first of all, here we've got the line of y equals 6. We've got the line here, which is x equals minus 3. Then we've got the line here. Now here we've got a gradient of, we go 2 across, 6 up. So the gradient there is equal to 1/3. Rather, that gradient, if here we've got 6 and here we've got 2, that gradient is equal to 3. So it passes through the point 0, 6. So this line here is y equals 3x plus 6. And if I take a look at this line here, well, I've got a gradient of minus 1/2, and it passes through the point 1. So this line is y equals 1/2 x plus 1. Don't forget the minus. So we've got the line y equals minus 1/2 x plus 1. So now, when we come to shade the inequalities, we've got values over here, x being greater or equal to minus 3. So I've got x being greater or equal to minus 3. Then I've got y equals 6. I want the values below that, so I've got y is less than or equal to 6. Then I want values above the line y equals 3x plus 6. So we've got y being greater or equal to 3x plus 6. And then here we've got values of y being greater than minus 1/2 x plus 1. So we've got y being greater or equal to minus 1/2 x plus 1. As we see here. Question number 17. The diagram shows two similar solid triangular prisms A and B. The volume of prism A is 58.806 centimeters cubed. The volume of prism B is 1587.762 centimeters cubed. The cross section of each prism is a right-angled triangle. For prism B, the length of the base of the triangle is 8.1 centimeters. The area of the triangle is 43.74 centimeters squared. The height of the triangle for prism A is h centimeters. We have to work out the value of h. Well, what we can do from here is find out what the height of prism B is. We've got 1/2 times by 8.1 times by its height, we'll call that HB, and this is equal to 43.74. And from this, we can find out what the height of B is. And if we work out what the height of B is, well, we've got 43.74 divided by 1/2 of 8.1. And it turns out we get 10.8. So we have 10.8 as the height of the prism B. So we have 10.8 centimeters as seen here. Now, because we know the volume of B and we know the volume of A, what we can do is find out the volume scale factor. The volume scale factor is equal to 1587.762 divided by 58.806. And if we work out what this is, well, we end up with 27. So now we can find out the length scale factor, and we can do this by cube rooting the volume scale factor. So we take our volume scale factor and then we cube root this. So we have the cube root of 27, which is equal to 3. So now what we need to do to find out what h is, h is equal to the 10.8 divided by 3, and it turns out h is equal to 3.6. So we have 3.6. Question number 18. Here is a triangle, and we have to work out the area of the triangle to 3 significant figures. Well, quite simply, the area that's equal to 1/2 times by 11.2 times by 4.3 times by the sine of 118 degrees. And if we work this out, we get 21.261, etc. So to 3 significant figures, we have 21.3 centimeters squared. Question number 19, we have to solve 6x squared plus 5x subtract 6 equals 0. Here is the quadratic formula. We've got x equals minus b plus minus the square root of b squared minus 4ac over 2a. If we find out the values of a, b and c, a equals 6, b equals 5, c equals minus 6. So if we attempt to solve, so we have x equals minus 5 plus minus the square root of 5 squared minus 4 times 6 times minus 6 divided by 2 times by 6. So if we work this out, we've got minus 5 plus the square root of 5 squared minus 4 times by 6 times by minus 6 divided by 2 times by 6. So one value is 2/3. And to find out the other value, we change this plus to a minus, and the other value then is equal to negative 3/2. So we get x equals 2/3 and minus 3/2. Question number 20. ABCDEFGH is a cuboid. AD is 9 centimeters, FD is 13 centimeters. The angle GHF is 49 degrees. We have to work out the size of the angle FAH to the nearest degree. Here is the information we know so far. AD is 9 centimeters, FD is 13 centimeters. The angle GHF, that's this angle here, is 49 degrees, and we have to work out the angle FAH, which is this, we'll call it x degrees. So what we can do to begin with is find out what AF is using Pythagoras. So if we were to find out what AF is, well, we have the hypotenuse 13. We square this. We then subtract 9. Squared. And then we square root. And if we work out what this is, 13 squared subtract 9 squared square root is 2 root 22, which is equal to 9.38, etc. So this length here is given as 9.38, etc. centimeters. Now that we know what AF is, what we can do is find out what FH is using trigonometry. Now, the length GH is also 9 centimeters. We know what this angle is, and we can use that to find out what FH is. We can recognize that the cosine of 49 degrees, that's equal to the adjacent, which is 9, divided by the hypotenuse, which is FH, which is what we're finding. So, if we were to find out what FH is, FH is therefore equal to nine divided by the cosine of 49 degrees and if we work out what this is, we get FH equals a value of 13.7, etc. So we have this length being 13.7, etc. So now we can find out what x is, again using trigonometry. We have tan x, which is equal to the opposite, which is the 13.7, etc., divided by the adjacent, which was the 9.38, etc. And if we work out what x is in this case, x is equal to, well, we have this value divided by 2 root 22, and if I take the inverse tangent of this, we get x equaling 55.63, etc. degrees, which means to the nearest degree we have 56 degrees. Question 21. The graph below gives the volume in litres of water in a container t seconds after the water starts to fill the container. For part A, we have to calculate an estimate for the gradient of the graph when t equals 17.5. You must show how you get your answer. Well, 17.5, that's over here. And so what we need to do is calculate the gradient of the tangent at this point. So we need to draw a tangent. So here is our tangent, and we need to calculate the gradient of this tangent. we can find out how much we go across by. So the amount we go across by is equal to 25 subtract 7.5, which is 17.5. So we have 17.5 seconds. And then we can find out how much we go up by. We are going from 0 to this value here, which is 18.5. So we've got 18.5 litres. And therefore, when we come to work out the gradient is equal to the change in y, which is 18.5 litres divided by 17.5 seconds. And if we work out what this is, we get a gradient value of 1.05. So to three significant figures, we have 1.06. Then for part B, we have to describe fully what the gradient in part A represents. Well, it's the rate of change of volume in litres over time, in seconds. Question number 22. F of x is equal to the cube root of x, g of x is equal to 2x plus 3, h of x is equal to f of g of x. We have to find the inverse of h. So, we know that f of x is equal to the cube root of x, and g of x is equal to 2x plus 3. We need to find h of x, which is equal to f of g of x. So that means this g of x is going to be substituted in to f. So we replace the x in f with the function g, meaning that h of x equals the cube root of g of x. So we've got g of x being cube rooted. So we've got g of x, which is 2x plus 3. And then what we do is we cube root this. So h of x is equal to the cube root of 2x plus 3. Then, to find out the inverse of h, our first step is to replace h with y. So we have y equals (2x plus 3) cube rooted. Our next step is to rearrange for x. So if I cube both sides, y cubed equals 2x plus 3, which means x is equal to y cubed subtract 3 divided by 2. And now if I swap the x and y, we would have y equals x cubed subtract 3 divided by 2, meaning the inverse of h is equal to x cubed subtract 3 divided by 2. Question number 23. A race is measured to have a distance of 10.6 kilometers correct to the nearest 0.1 kilometers. Sam runs the race in a time of 31 minutes 48 seconds correct to the nearest second. Sam's average speed in the race is v kilometers per hour. By considering bounds, you have to calculate the value of v to a suitable degree of accuracy. You must show all your working and give a reason for your answer. So, if we consider the distance, the lower bound is 10.55 kilometers, the upper bound is 10.65 kilometers. If we can now consider the time, well, so far we've got 31 minutes and 47.5 seconds for the lower bound. For the upper bound, we've got 31 minutes and 48.5 seconds. We can convert all this into just minutes, and then we can convert it into hours, because our final answer needs to be in kilometers per hour. So if I take this 31, and then I add this 47.5 seconds, and if I divide that bit by 60, we get a value of 10.791 etc. minutes. Let's store this into A, just in case we need it later on. So that's our lower bound in minutes, and if we find the upper bound, well, we have 31 plus 48.5 over 60, so we end up with 31.808 etc. minutes. So let's store that in B, just in case we need it later on. So now what we can do is convert these to hours by dividing through by 60. So if I divide A by 60, we get 0.529 etc. hours for our lower bound for the time, and for the upper bound, well, before we do anything else, let's store this into A. And if we take our value of B and then divide that by 60, we get our upper bound shown here. So let's store this into B. Now, for us to work out the speed, well, to work out the lower bound of the speed, we've got the lower bound of the distance, and then what we're going to do is divide this by the upper bound of the time. So if I work this out, I've got 10.55 divided by B, which is this value here. So I get 19.900445538. And for my upper bound, I've got the upper bound of the distance divided by the lower bound of the time, as we see here. So here is the lower bound of the speed, 19.90 etc. And to work out the upper bound, I need to do 10.65 divided by this value of A, which is 20.099 etc. And therefore what we can conclude is the speed v is equal to 20 kilometers per hour, and that's because both the lower bound and the upper bound round to this value. Question number 24. A circle has equation x squared plus y squared equals 12.25, and the point P lies on the circle, and it's got coordinates 2.1 and 2.8. L is a tangent to the circle at the point P. We have to find an equation for L in the form y equals ax plus by equals c, where a, b and c are integers. Well, here is a diagram of what's going on. We've got our circle, we've got the point P, and what we need to do is find the equation of this tangent. So, the first thing we can do is find out the gradient of the radius. So the radius will be this red line here. So the gradient of the radius, that is equal to the change in y, which is 2.8, divided by the change in x, which is 2.1. And if we work out this gradient, we would get a value of 4/3. So that means the gradient of the tangent is the negative reciprocal of 4/3, which is -3/4. So we can find out the equation of the straight line. We have y subtract the y coordinate of 2.8, which I'm going to rewrite as 14/5. So this 14/5 is equal to the y coordinate of p, and this is equal to the -3/4 multiplied by x subtract x1, which is 2.1, which I'm going to rewrite as 21/10. So now we need to simplify all this in an integer form. Now, first of all, let's multiply through by 4. So that means I would have 4y subtract, well, here I would have 14/5 times by 4, which is -56/5. So I subtract 56/5, and that's equal to -3 multiplied by x subtract 21/10. And what I'm going to do is actually expand all that out. So I've got 3 times by x, which is 3x. Then I've got -3 times by -21/10. So I get positive 63/10. And now I'm going to multiply through by 10. So if I multiply through by 10, I have 40y subtract. Now here I've got 56 divided by 5 times by 10, which is 112. And that's equal to -30 x plus 63. So now if I add 112 to 63, I get 175. So I've got 40y plus 30x equals 175. And if I divide through by 5, what we end up with is 30x plus 8y equals 35. So from here to here, what we did was we divided through by 5. Here we multiplied by 10. And here I multiplied by 4. So this is the equation of the tangent